Hello everyone. Thanks so much for joining. This is our second Diagrid Catalyst webinar. And if you haven't heard yet, Diagrid Catalyst is a new product that we just released here at Diagrid, I guess a few weeks ago now. And they are a set of unified APIs for messaging, data, and workflow. So today, myself and Bilgin Ibryam are going to walk through kind of what is Diagrid Catalyst and gives a few demos, and then hopefully leave some time for Q&A at the end. And if I haven't had the pleasure to meet you before, my name is Alice Gibbons. I am a customer success engineer at Diagrid, and I'm here with Bilgin Ibryam.
Hello, everyone. Bilgin Ibryam. I'm product manager at Diagrid, joining Diagrid from Red Hat.
Thanks, Bilgin. And so we are excited to tell you about Catalyst today. Our agenda is going to be, I'm going to talk a little bit about some distributed application challenges, as well as, how Catalyst solves these. And then I'm going to get into what the Catalyst APIs really are, and then show a demo of the local development experience with Catalyst. From there, I'm going to pass it to Bilgin, and he's going to show one of our patterns that is supported with the Catalyst APIs, and it's the Outbox pattern. He's going to show that on the cloud with Catalyst, and then we're going to leave some time for Q&A at the end. And also there is a Q&A functionality chat in the Zoom webinar on the bottom. So I believe if you can ask your questions there, we have some moderators as well that'll be checking those. Thanks so much for joining. Excited to be here. So I'm going to start a little bit talking about some of the development concerns that, developers have to take into account when they're developing apps. So, there's always been these sort of three different ways to kind of go for networking, compute, and storage in terms of every single app has to think about those when you are building them. But, there are a ton of different requirements that are coming out these days for things around distributed applications and polyglotism, as well as multi-cloud apps. And these are specific. These really cause developers to think about so many different things when they are developing. For instance, you have different languages that are good for a variety of different things, different communication protocols and libraries, HTTP, gRPC, AMQP, from a networking perspective that really, would be good for different use cases within your apps. And then, on the data or the storage side, you also have different data stores that also are good for different use cases and patterns. So for instance, using a key value store versus using an object store or a document database, etc. And, the whole point here is that regardless of all of these different development concerns and requirements, we do not want to expose that complexity to developers. And so these concerns are kind of only just growing, especially with the requirements kind of coming in in the cloud native space. And I think, if you think about what this looks like in practice, we can take a simple distributed application here. And this might be running on multiple platforms and maybe in different programming languages. So some of the business operations that this app might do are things like, starting or running a stateful workflow, invoking another services method, maybe synchronously, or publishing and subscribing async between services. A system that implements, any of these patterns typically is required to depend on, numerous SDKs, libraries, and different dependencies across the apps. In order to implement all of these patterns. So, maybe you need a different SDK for the request reply pattern than you would for, your pub sub implementation. Similarly, the interaction with the infrastructure layer is often language and service specific. So, publishing a message to Redis typically requires you to use the Redis SDK in whatever language of choice that you're using. And this typically requires other services to reinvent, the same patterns and the same use cases over and over again in different languages and on different platforms. And of course, the more dependencies that you take on in your code, the more the attack surface area grows. And really, the larger the supply chain can lead to an inconsistent security model across your system. And so, all of this leads to increased developer complexity, really. And, building these distributed apps has become a lot for developers to deal with on a day-to-day basis. So the sheer amount of, and this leads to code fragmentation, leading to essentially slower releases of unreliable and insecure applications, just with, all of these complexities kind of taken on board. So what does this look like with Catalyst, and what's the problem that Catalyst is trying to solve? with Diagrid Catalyst, we are providing a consistent API surface, for common application challenges that essentially gives you a new level of portability and reliability at the application layer. So for instance, I took the very same app. So, if I go back to my previous slide, this is the very same application as before. And I replaced this with these Catalyst APIs. And, instead of having to take all these dependencies on different cloud services and different platform-specific implementations of patterns and practices, you can remove all of these language-specific and infrastructure-specific dependencies, allowing you to not only write cleaner code, but also take advantage of, the built-in cross-cutting concerns in the platform for observability, security, and resiliency. And hopefully we're going to get in and show you how some of these things work in practice today. But you can see this is the same as before with some of the same patterns in terms of workflows, service invocation, publish and subscribe, as well as state. Okay, so what is it? What is it really? It is a set of APIs. So we are hosting a set of these APIs for messaging, data, and workflow that you can access from any cloud platform. So you can kind of see on the very top here, you have your application, you're still hosting that application wherever it's running, whether that would be, on any cloud or on premises, on your favorite development or platform of choice. And then you are taking advantage of these APIs. So we're providing a set of 5 different APIs, again, for like data, for workflow and orchestration and bindings. And we are providing as well these cross-cutting concerns for observability, security, and resiliency. And then you can also take advantage of both your existing infrastructure. So if you run, with cloud infrastructure on cloud targets like AWS or Azure, you can take advantage of those. Or we're also providing managed message broker and database for you to use to essentially kind of get up and running with Catalyst really quick or offload your infrastructure management to Diagrid. And these are all powered by open source Dapper. So we are completely compliant with the open source Dapper project, and these APIs follow the same specification as the open source Dapper spec does today. So with that, I wanted to get into a few of the core concepts and then jump into a quick demo. The core concepts that I wanted to talk through within Catalyst are the application identity and connection core concepts. So essentially, you can see on this slide here, I have my application, again, that's running on any platform where you're already running that, locally, it's running on GCP, it's running on AWS. And then, I have this idea of an application identity. And an app identity is essentially like a device twin or a service twin that you have to create within Catalyst to allow you to have a centralized identity idea that you can add, resiliency and observability and security features on top of. And this works by, you create this application identity and then you call out from your application code to that app identity that you created in Catalyst. And today we provide API token authentication from your app to that application identity that we host. Also, if you have your application identity and it's calling back into your app, then that is when we also can use app token authentication as well there if you want. And again, this is powered by Dapper. So these are the complete, the same specification as the open source Dapper APIs that that are proven and have been used, across many different production deployments. The other concept I want to talk about briefly was the idea of connections. So you have your service twin, and that's living in Catalyst, right? Now, the other thing you want to do is create a connection to infrastructure. Now, there's many different infrastructure targets that you might want to connect to, message brokers and databases, which, we are also providing our managed versions of. But if you also want to use your existing cloud infrastructure, if you also want to take advantage of, Azure Service Bus or AWS SQS, because, you've been using that forever and that's in your architecture, then what you do is you create a connection within Catalyst, and this allows you to call out to that infrastructure directly from your code, but still keep your code portable and agnostic entirely in that process. And so I'm going to show what this looks like, but I just wanted to call it. So those are the two main concepts that we deal with in Catalyst. Okay, so let's get to a demo. The local demo that I'm going to show today is going to have 2 applications, and I'm going to be running both of these locally. It's going to have a producer application and a consumer application. My producer app is a Python application, and it's going to be running, I'm going to be running it locally. And what it's doing is it is going to call out to its, application twin that I talked about, or app ID living in Catalyst. And then that is going to be publishing a message onto a pub sub broker. In this case, I'm actually going to be using the Diagrid pub sub broker, but again, you can totally swap these out. This is just for testing purposes. And then this is after we publish a message on that broker, I have a consumer application. Again, I'm going to be running this locally, and this is going to be picking up all of the messages so that because it's subscribed to that an orders topic onto that same that message broker. And this is a .NET application, and what the .NET application does is it picks up that message and then actually saves it into a state store. And in this case, I'm using also the Diagrid key value store just to show you kind of how quickly I can get up and running with my 2 local apps. Okay, so let's get into it. So I'm going to jump now into the application portal, or the Catalyst portal. So you can see here, I have a completely blank Catalyst project. Essentially, this is the Catalyst dashboard, and you can see I have a number of things on the left-hand side here, but I don't have any projects. So what I'm going to do first is I'm going to create a new project. This is going to be, I'm going to call this Catalyst Webinar, and I'm going to choose which region I want to deploy it in. Today, we are deploying primarily in AWS US West, and that is just due to, that's where our data plane is deployed today, and we're going to have many other regions available as well as other clouds. There's a number of services that I can choose as well to be enabled within this project. So again, you can think of a project just like a grouping of resources, or like, you want to have a project for pretty much your entire application. And within that application, you might want to take advantage of our managed services. So I'm going to make sure that my pub sub broker and key value store are both enabled. And then we also have the option here of enabling managed workflow. So essentially that's to take advantage of the workflow API, the stateful workflow API, and run long-running workflows within your applications. So I'm going to kick this off, and this is going to go into processing. And then as this is going into processing, what it's going to do, you can see, and here it's my region. It's also going to create those managed services for me, because that's what I said. So again, I have this pub sub message broker, which we are hosting for you completely serverlessly and kind of a scale as you go format. And then similarly, the key value store. So these are gonna spin up for me. And then I have their associated connections as well. So if you remember the idea that I was just talking about for connections, essentially what the connections are, and these are being auto-created for me, are the way that you can connect from the APIs into your infrastructure. So, because these are Diagrid connections, and you can see that this target is a Diagrid type, then essentially what we have here is, these are again being created while my managed services are being created, but we have the ability within each of these to add things like a resiliency policy, or add things like scopes that will allow you to, call out to the APIs and call out to your infrastructure, but actually get, for instance, outbound resiliency for a retry policy, for a timeout policy, or circuit breakers onto this like distributed systems call. Similarly, we have the idea of scopes. So this allows you to scope down the services that you're using and only allow certain applications to talk to them. Awesome. So while that is going there, it looks like, if I go back to projects for a sec, my project looks like it's ready. That's great. I'm going to start by creating 2 application IDs. So again, just as I had that connections core concept, I also have my application ID core concept, and this allows me to, create these application twins within Catalyst. So I'm going to create one here called producer, and this is going to be that producer application for my local code locally. Producer, and then I don't need to connect it to any existing app yet, because again, I'm just running locally. But then I also have the ability in the UI to add any resiliency policies for, service invocation calls when calling this application. I'm going to click create app ID. And this one's going to be processing as well, and hopefully go ready pretty quick. The other one I'm going to create is the consumer app. And this is going to be my subscribing application, and this is going to be a subscriber to that producer app. Again, it's going to be linking back to my .NET app that I'm going to run locally here. I'm going to create consumer. I'm not going to connect it to an existing application yet because I'm going to use some of the local Diagrid dev tools to do that. But this would essentially, I would enable this, or I'd allow this to be connected if I wanted to send or like create a path from the Catalyst app ID into my application. So, and we can show that in a little bit later. I'm going to create this one. Now you see my producer is ready. It's great. And then my consumer is still processing. So flipping over now to Visual Studio Code, I'm going to show you the apps that are going to be I'm going to be using within my demo. So again, I have two applications, producer and consumer. As I said, this producer is a pretty simple Python app. It is using Fast API. It has essentially all it's really doing here is publishing an order onto a message broker. So you can see here, I have this publish orders topic or publish orders method. And what it's going to do is it's going to create the regular open source Dapper client. So this is an important part because essentially we're using the regular open source Dapper SDKs, just as you would if you were going to be coding with open source Dapper, but we're going to be taking advantage of, these managed APIs that we're providing. So essentially, I create this Dapper client, instantiate the Dapper client, and then I, using the method call publish event, I'm publishing a message onto, a pub sub broker. I'm giving it the topic name, and then I'm giving it, the message I want to send, which in this case is just an order message. And then I print out a success message. That's great. And then the other things I wanted to call out here are just these environment variables. So these environment variables are really important because they are how my code knows where to talk to from the Dapper SDK. So essentially, I'm going to give it this HTTP endpoint, a Dapper API token because it's using API token authentication to talk to Catalyst. And then, these two are just if I want to, change the pub sub name or the pub sub topic. On the subscribing side, I have a C# service. Again, fairly simple application. It's running its .NET 6, and it is going to be also using, the standard Dapper client that you would be using if you were going to be coding against open source Dapper SDKs. What all this does is it has a method for the /new orders route. And what it's going to do is it's going to bring in that order and it's going to, print out a success message and then essentially save this into a state store. So this state store, in this case, is reading in from an environment variable, the name of the state store it's going to reach out to. But, it's using that Dapper client and then calling out to save state async. And then it has some error handling. So publisher, subscriber, and then saving state is kind of the flow there. And then, so what I'm going to do is I'm going to use the CLI here. So I'm going to do a quick login. So we also have everything that I showed in the user interface. You can also, of course, create the app IDs or do anything else within the CLI. And what I'm going to do is so you can see that I have these two application IDs that I just created. Again, my producer and my consumer apps, and they are both have a ready status, and that's all they have so far. Nothing too crazy. From there, what I'm going to do is I'm going to use these, or I'm going to go into the UI and I'm going to grab the environment variables that I need just to rig this all up. So if I'm going back into the producer, all I need to copy really is this API token. Essentially what I'm going to do is in my producer, I'm going to say, I'm going to paste that in there. And again, this is the value that I copied from the browser here. And then I'm also going to copy this HTTP URL. So these HTTP URLs actually do routing as well as they do routing from your application into the APIs. So essentially it says which project I'm denoting within Catalyst. So I need to set that one as well. And that is just and again, these are just in the code here. So Dapper HTTP endpoint, and set that guy. That looks good. And that's all I have to do. Besides that, I literally can just kind of run my application with the Diagrid dev commands, and it should automatically talk to Catalyst just with the regular Dapper SDKs. Okay, so the command that I'm going to do here is called Diagrid. It's one of the Diagrid dev commands. So this is the Diagrid dev start. And what this is going to do is it's going to start both my application, and it's going to start it with any of the run commands that I would like it to, as well as start streaming the logs to my terminal here. So if I go producer, again, I'm going to start it with the producer app ID, because that's what I named my app ID in Catalyst. And then I'm going to give it my start command, which for Python is just this guy. So I'm going to kick that off, and then you can kind of see a couple of the logs that are printing out. So what's this? So essentially, I started the producer up. This is running, and then you can see these are my application logs. So these are my Python logs streaming directly to the browser here. That's great. Let's test to see if this is working. I'm going to just do a quick test call. I have this I have the REST extension installed into VS Code, but this is essentially just like running a curl command. And I'm going to do a quick, test by seeing if I can post a quick order to, localhost 50001, which is where my producer is running with this order ID. So that's great. This looks like it was successful. Looks like I had published successful, and I published that order 100. Cool. So it's connecting up to Catalyst, and it was able to successfully publish onto, my pub sub broker. Let's connect up the consumer and see this end to end. So on the consumer side, what I'm going to do is I'm going to do the same thing, except I have to get those endpoints again, or get the environment variables again, just from my consumer app ID. So I copy that API token from the portal, and then I go back and I do export. So that's my Dapper API token. You can see it's the consumer one, which is correct. And then I'm going to do the Dapper gRPC token as well, because this is using gRPC to make a call out to the state store. I'm going to copy that guy. And then last but not least, I'm going to copy my state store name. So essentially the code here is expecting a few of these environment variables, as I mentioned before, and this one is the state store name by default is state store. But if you remember from the UI, when I created my managed services and I have these connections, I actually have the Diagrid state store is actually named KB store. So all I'm doing here is just really providing it the name of that managed connection so that I can get it into my application. So I did that, and then last but not least, I have to create a subscription. So I have almost finished wiring everything up. The last thing I need to do is create a subscription, and I'm going to do that within the portal as well. So creating a subscription here, I'm going to call it orders sub. This is going to be connected to a pub sub connection. In this case, again, this is the Diagrid pub sub connection. And then this is an important part because I need to choose a scope for which that subscription is going to point to. In this case, my consumer app is the one that wants to pick up those orders. And so I need to tell Catalyst to where to send, or, where to send the messages that come into this pub sub message broker. The topic I'm going to use here is just going to be called orders. So that's the one that we have specified within the code in the publisher. And then the last but not least, the route that I need to send it to on the subscriber or on the consumer is just going to be new order. And we can actually just double check that new orders based on the code. So this subscription I'm going to create, and you can see it should spin up pretty quickly here. But again, this is just going to connect kind of my infrastructure to my subscribing applications and ensure that I'm picking up those orders. So those look ready. That looks ready too. And then hopefully this should be ready in a second here. But then all I have to do is start off my consumer app. So I can do again, build. just to ensure everything's built. And then I'm going to do a similar command. It's going to be Diagrid dev start, except in this time, the only difference really is I'm going to be providing it this app port argument. And this app port is just going to tell the Diagrid dev start tool where that my application is running on my local machine. And this is actually going to create an application connection or a dev tunnel from Catalyst and route all of the events that are coming to this app ID to my local machine here. So again, I'm just going to quickly confirm. Yeah, so that order subscription is ready, which is great. And then when I do run this guy, looks good. So you can see it's going to show a few of the same commands. So it's starting up the consumer. Again, that's the application ID. It's built that successfully. And then you can see some of these application commands, again, from the .NET app that's actually being run. So that's listening on 5002. And then it will actually connect to this app ID consumer within the cloud, and then actually pipe all of those orders, hopefully, back to my local machine. So yeah, there you go. Great. So I had this, connected app ID consumer to my local host. And then I had this, as soon as it got connected, I should be able to send a message and see it all the way through. So hopefully this works. So let's do this. So again, I just sent a message via my test.rust extension. This just said, on my producer, this was this published successfully, order number 2222. On the subscribing side, I got a bunch of logs, but essentially what happened here is I received this order app with order ID 2222, and then I persisted it within that state store. Again, I'm using the Diagrid KV store here. So the way I can double check that this worked end to end is by heading back to the user interface, going into, my consumer app ID, which is the one that's doing that persisting. And actually, while I'm in here, I just wanted to call out, you can see that since I have this local dev tunnel set up, I actually have the app URL for my app connection actually has been changed to, my local instance running here. So this is just telling me this on this side, this is essentially how Catalyst is connecting to your local or your applications. And right now it's just saying it's connecting via a local dev tunnel, and it's showing that just via this local.cra.diagrid.io. So to prove that, this was in fact actually saved in the state store, I'm going to use what's called the API Explorer within Catalyst. This is a API Explorer that allows you to, test any of the APIs that we have available. And I'm going to do a get onto the key or the order number that I just published. And this was order number 2222. Essentially, I only have that KV store, the Diagrid KV store now. And you can kind of see that the request came back successful, and it gave me, hey, that was order ID 2222. That was in fact saved in the state store. Okay, last but not least, before I hand it over to Bilgin, I'm just going to send a bunch of bulk orders through. So this request, what it's going to do is it's going to send 100 orders all at once through my publisher, my producer, to my consumer. And it's going to, you can see it kind of going crazy here. So on the producer side, it's publishing 100 different orders, and then the consumer side, I'm going to be receiving all these guys. And looking at this in the portal, what I can actually see is I can look at a bunch of the logs that are made. And these are, specific to all the calls that have been happening. So I have both inbound and outbound calls being made, and this is inbound to Catalyst. So essentially like inbound, inbound to the application ID. And then, in this case, I'm actually making an outbound call from to this new orders call, which is, to my application, to my subscriber application. And then the other inbound call you'll see here is when I'm actually saving that state via gRPC through the Catalyst state API. Similarly, I can take a look at some of the metrics that are coming through. Let's just change this to 5 minutes because we haven't been doing this for 30 minutes. And I can see kind of some of the golden metrics from what I've been running. So I can see that this latency, what the latency's been doing. I can see I just ran that get just to double check my order. I can also view the RPS. Yeah, again, more of the save state in here as well. And then no errors, which is great. And then last but not least, if I head to the visualizer page, this is This is a page that allows me to view. This is a page that allows me to view the applications on, maybe this isn't my live demos. So essentially this allows me to view the apps and how they talk to each other. But right now they're not showing. But essentially what it typically shows is it shows that these will be connected and these will be showing metrics in between how they're talking to each other. I think it's just probably taking a quick second to load. So maybe when we come back, it'll be showing. But essentially, yeah, there's lots of different ways to view your metrics and to kind of see what's actually happening within Catalyst. But yeah, so with that, I want to pass it over to Bilgin to talk about how we kind of can use some of these APIs to build like real life patterns in distributed apps and show a quick demo as well.
Oh, thanks, Alice. Great demo. Let me share my screen. You know, if you can see my screen.
Yeah, looks good.
All right. So now that you have seen what Catalyst can do from Alice, and maybe let's try to answer what really is Catalyst and how it helps for developers to increase the productivity. Some of the well-known ways to increase developer productivity are use things such as libraries, frameworks, and a platform. And if you define those, you know, library is a set of predefined functions that you add to your application and you call them, right? And typically libraries are very focused and they offer limited benefits. jQuery is an example of a library. Another way to increase productivity is to use a framework, and a framework is an abstraction that gives us, you know, a structure where we add our codes, and it runs our code and calls our application. You know, it gives extension points for the codes to plug in, and it does things for us. A good example here would be AngularJS in JavaScript and Spring Framework in Java. You know, typically frameworks are very powerful, but they enforce certain constraints in your application. And platform is a thing we stand on. In case of software, it's a thing we run our application. The interaction between the application and platform is pretty limited, typically to health check. Examples of platform would be Kubernetes and even AWS Lambda. And the idea of Diagrid Catalyst is basically to give you the same level of benefits that a framework gives you, but without its limitations. For example, by now you know that Catalyst is not running your application. So you would run your application on some kind of a platform by choosing your preferred language or even framework on preferred compute, and you call to Catalyst APIs. Catalyst will also abstract the infrastructure, the backend infrastructure your application is consuming, but it's not only abstracting the infrastructure, it gives you additional capabilities that you can consume through its APIs. So a way to think to Catalyst would be, it's almost like a cloud middleware that helps you connect and glue together various services, which we'll see in the demo later. So why would you use these APIs? Alice demonstrated how to use the PubSub API. You know, one of the benefits is it abstracts the actual broker infrastructure, but that's not the only reason. For example, when you use the Catalyst PubSub APIs, you know, you get additional capabilities that might not be available in the underlying broker implementation, or it may vary in terms of how it's implemented or how it's exposed to the user. For example, with the PubSub APIs, you get capabilities such as, you know, dead letter topics, which is different in Amazon SNS and RabbitMQ. You know, you get at least once delivery. You can apply circuit breakers, retries. You can even enforce TTL, regardless if it is available or not in the backing broker implementation, and other things such as, you know, access policies and message routing to different applications. Another API is the state API, which basically provides an abstraction, key value abstraction on top of different databases. In addition to hiding the implementation, it gives you additional capabilities, such as concurrency control and data isolation, things that can be painful to implement in, let's say, in Redis. Yeah, you can do data encryption, again, circuit breaking and retries. You can enforce TTL, regardless if it is supported in the database implementation or not. The Catalyst layer can ensure that. Again, you have access policies, and you can even implement something like a transactional outbox, something that is available, for example, in Amazon DynamoDB, but can be really difficult to do with Postgres where you require some additional tools such as Ibryam. And I would say the real power of this API comes when you start combining them. For example, if you use a workflow API, the different stages of the workflow, you can use PubSub and request reply, or you can combine the state API with PubSub using the transactional outbox, which will ensure every time you write to a state store using the state API, those changes are emitted to a message broker, which then can be consumed by the same or a different application, a very powerful pattern, which we'll demonstrate shortly. Yeah, these are some of the reasons why would use Catalyst APIs. And for the demo scenario, what we will do is we will try to connect, let's say, 5+ different cloud services in a single app and demonstrate how these APIs are powerful. So let's go to demo setup. So to demonstrate this connectivity, we have created a fictitious application that lets you find the right recipe, food recipe, right? And it has, I'd say, quite common architecture for web applications. So for the front end, we have used a tool called Retool, which lets you create powerful dashboards and forms, so backend business applications. And it is very powerful in connecting to different data sources and performing CRUD operations. So it can, write to different data sources and read the data. What we will do is we will extend that into a pattern that is known in the serverless, like a state first. Basically, we will store the state into a database. And for that purpose, we'll use a Neon, which is a serverless Postgres compatible database. Then we will use Catalyst Outbox feature to emit the changes into a PubSub message broker, which will use a Diagrid managed PubSub broker. These changes will be consumed by a function that is running on GCP, Python function that calls a food API to grab a recipe and write the recipe back to a database, then show it in Retool to the user. So let's see how the app looks like. Okay, I need to move the Zoom controls. Let's go to the recipe maker. This is how it looks like. So it has 3 panels, and the top left is where you submit your recipe request by setting certain criteria. What's the meal type you want? If you have any dietary requirement, what's the difficulty levels and additional restrictions. Right now it's broken because we don't have the backend yet in Catalyst. But once you submit this request, it will get recorded and shown on the top right corner, which is a list of requests. And each request then will be emitted to the function on GCP, where we'll find the right recipe using calling the external food API, and we will show the recipe in the bottom panel. That's the UI. Now, if you go to Catalyst, what we need for that is we need a certain backend infrastructure. Similar to Alice's setup, I have created a project in Catalyst, and while creating a project, I've also requested a PubSub broker. So I have the PubSub broker, but I don't have a database. So what I'm going to do is I'm going to create a connection to a database. For your record, the database is provisioned on Neon. Here I have a database that's called demo that has the tables that have been created by earlier on of this sample. So let's go and create a connection. You can create a connection using the UI or the CLI. If you have it already created, you can upload a YAML file but what we'll use the wizard to do that. So I'm creating a connection to a state store, and the type of state store is Postgres. That's what Neon provides. Here I'm deciding which application should I have access to this state store. In this case, both application needs access, so they are both selected. How am I going to connect to the state store? I have a configuration string, which I have copied from Neon. It is right here. So I'm going to copy the string. We have to name this connection. So I'll be super creative and I'll call it database. And I have a number of configuration options. So one of the important one is what's the isolation level of the collection between the various applications. So in this case, both of the applications I'm going to create will be sharing the same collection. So I'm going to set not to prefix any of the app IDs, so key prefix is none. And I want to use the Outbox capabilities. So I want all changes from this collection to be emitted to my PubSub message broker. So if I find for Outbox PubSub name, the name of the PubSub broker is PubSub. Fix that. And the topic where all of these changes will be emitted, let's call that Outbox. I have options to configure resiliency policy. This is how Catalyst will interact with the Neon service. I'm not going to enable any of that, so no resiliency policy is enabled. And with that, if I don't have any mistakes, it should set up the connection. In addition to connection, I also need app IDs. App ID is the way to talk to Catalyst and for Catalyst to talk to your applications. And I have created two app IDs. They are plain app IDs, no configuration. Well, the first app ID is called Retool, and it represents the front-end Retool application, right? I want to have a twin replica of that application in Catalyst so that I can control specifically what access I'm giving to that application. I want to see its metrics and logs and so forth. And the app ID is a processor. We'll go to that next. So now let's go to Retool and connect Retool to this app ID. To do that, I'm going to copy the URL of this app ID, and I'll go to Retool, and this is the Retool configuration. This tool can connect to various data sources and APIs. So this is API type of connection, and all I have to do is I have to set the URL right to my app ID and the token that identifies which app ID to connect to. So if I set the token and save these changes, at this point, I can see that my database connection is also established to Neon. Let's see how the recipe maker is working. So if I submit this request, all right, the demo votes are working. I think I've saved the configuration, right? If I go here, maybe I have to refresh this. And let's try one more time to save a request. All right, I think I have a mistake. Let's go to Catalyst and check what was the mistake. My apps are up. My connection looks healthy. And the error message in Retool is quite rapid. PubSub. All right, I think I have a typo. I have a typo in my database configuration. Yes. Okay. Rather than pointing to the broker, I pointed it to a non-existing broker. So what I'm going to do is, in a minute, I'm going to recreate that in the fastest way possible. So we said it's a state store connecting to Postgres that all application can access. Right. I have the string connection string, and the connection name is database. I don't want any kind of prefixes. And this is where my mistake was. The name of the broker is pops up, and the topic is Outbox. So double checking this. All right, hopefully this time connection will be right. And once the connection to the database is established, we should be able to submit requests. Okay, while that's happening, I will now go forward and configure the processor app ID. So this app ID represents the backend application. That is that's the function that will consume the messages from the Outbox and find the recipe. Right. Let's see how's that function look like. The function is written in Python, and it is using the Dapper client SDK. Okay, what the function does is it basically gets the change events from the Outbox topic. Then it calls an external API, the Spinacular Food API, to find a recipe that matches the request. Once it finds a recipe, then it will use the Dapper SDK to call back to the processor app ID and store the recipe in the database so that we can display it in the UI, right? And as you can see here, to do call back to Catalyst API, we are using the Dapper SDK, and the two things we need for that are the URL back to the Catalyst API and the token. And I have set those right now in Google Functions. You can see as environment variables, they are pointing back to my processor URL and app ID. But I need to do one more thing. I need to tell this app ID how to call the Google function. And I can do that by connecting this app ID to the application. I have the URL, the Google function here. So if I set that, I made the Google function public, so there is no authentication token required. I'm going to save that. If all the configurations are right in place, I should be able to do request, local request. Okay, now we can see the first part is working. I can actually write to the state store. And once the configuration to the Google function is applied, it should be also delivered there. I should start getting recipes. Let's check where we stand. Yes, our app ID is being updated. Now it will start consuming any events in the Outbox topic and push them to the function. Right. All right. In the meantime, we can I can show you what's the code in here. So if I go to the configuration, how the application works behind the scenes is this form, the form on the left-hand side, calls to the Catalyst API, to its state API, and performing upsert operations. So this is basically performing write operations into the state API. And the panel on the right-hand side is listing all the requests. These are recipe requests. You see, it is basically querying the state API, the database connection, and the query type is give me all the request true. And the bottom panel is a very similar. It is querying the state API, but this time it's querying or results rather than recipes. Okay, the application IDs are back. Let's try one more time. Let's now request a main course that is not vegetarian and that's hard to make and that has no rice. Let's say, if I submit that, our query is recorded and both of the recipes have appeared and they're coming from the food API. We've also implemented delete operation. You can delete any of these records that will call the state API and delete the entry. To see how this works, we can try to show, see what we get in the visualizer. So Retool was the front-end application that stores the data in the database. You can see it stores the request to the database. And if I go back to the application, the processor is the one that picks the changes from the PubSub broker and uses a Google function to process them and stores the result back into the database. We can see these same interactions for all application IDs using the log format. For example, let's see if I can find the delete call I made earlier. You can see it called the state store API and performed delete. And all of these other calls are because the UI is constantly querying the API and so that to refresh the tables. Just to verify, you can see that we also have our data in Neon. All right, that's the demo. Let's move on. In terms of next steps, what we could have done more is, for example, we can enable resiliency policies when we are calling the function on Google Cloud in case if there are any failures. In addition, within the function right now, we are calling the food API without using Catalyst with simple HTTP call. That can also go through Catalyst where you would get all the benefits of resiliency, observability, security. We can change the message broker to use something like an external broker, for example, a cloud service from Confluent, let's say, and you can also offer some of these APIs to Retool. Right now, Retool doesn't have ability to easily publish messages or to consume messages and update the UI, so all that can be done, combining Retool with Catalyst. That I'll hand over to Alice. I think my screen, okay. Yeah, my screen is just loading.
Awesome. Yeah, good job, Bilgin. Way to persevere through the demo.
Yeah.
Yeah, so thanks everyone for joining. I know we have about 5 minutes left. If anyone had any questions and wanted to jump off mute, we have a lot of really great resources that can answer any of the questions. Also, we are just posting, if you want to take a quick screenshot or head to any of the URLs on this page, we have both the early access. So Catalyst is entirely in early access right now, meaning that it's available free, and you can sign up for our waitlist on our website. Or at Catalyst-early-access. Also, all the code that we use today is public on our GitHub repository, Diagrid Labs, both the retool demo that Bilgin just showed that uses Outbox, as well as the local demo as well that I showed earlier. And yeah, we also have some great documentation that has some quick starts that can get you up and running in less than 5 minutes, as well as some cloud tutorials on there that make it really easy to get started with the cloud resources.